All right. Well, everyone, welcome. Thanks for coming to my talk. Excited to be doing BB Dev Days for a second year in a row. This year, in some ways, is building off of last year's work, where it's trying to introduce people to different ways to incorporate data from your Blackbaud API into other data sources. So let me walk you through today this journey of how we developed a government data strategy at the downtown school using a combination of our Blackbaud education management, Sky API, Airbyte, and BigQuery, and I'll explain what those are, of course, as we go. Just a couple of quick logistics. My name is Hudson Harper. Of course, I'm the director of tech and institutional research at the downtown school. We're a fairly small, new school in Seattle, so if you've never heard of us, that's probably why. Happy that we're in our 6th year. And I don't know, just want to point out that even though I've been working in independent schools pretty much my whole career, I've always been a huge data and math nerd. You can see I've gotten no less cool from high school to now. Also, other piece of logistics is I have Rob from Blackbaud. He's a customer success manager. He's joining us in the chat. So if I don't see questions, he'll point them out to me. So please put questions in the chat for Rob to relay to me. All right, so a few just goals for this presentation. One is just to talk about the strategy for building your data governed data infrastructure. So what are some of the things to consider? I know in particular, there's often a lot of emphasis on, what's the bigger data strategy? What should we be looking at? But then it's a whole lot of conversation to talk about, well, what does that look like technically in your infrastructure? I'm going to give you a demo of how we are using Airbyte for extracting data from Blackbaud into other sources for via Sky API, and then also talk about a couple of the use cases that other K-12 schools, but really, any organization could perhaps see some value in, taking their data from Blackbaud, putting it somewhere else. All right. So when talking about building a data strategy, all right, it helps to take like a very top level, like a 30,000 sky foot view of, what are the components of your infrastructure going to look like? And really, if we look at industry standards for how, these large companies are organizing their infrastructure, it typically falls into at least 3 layers, right? So I would say these are the minimum number of layers that you need to really produce mature data workflows that are going to be future-proof, all right? The first layer is to have some piece of data orchestration. So this is some sort of tool or platform that allows you to take data from one source and put it into another place. All right. So if you've heard ETL, extract, transform, load, this is where that ETL is happening. And there are a number of tools. A lot of people at this conference are presenting about Power Automate. That is an example of a data orchestration tool. If you have programming experience, there are a couple of great Python-based options, such as Mage AI and Prefect, but we're going to be focusing on Airbyte. The second layer of your data architecture is the actual storage of your data, all right? And some of the most common architectures that you see for data storage are data lakes, which are great for storing unstructured data. So think like your text and your PDF files. Maybe you have images, old invoices, that sort of thing, right? Those can go into your data lake, and you can enhance those unstructured pieces of data through things like metadata or tags. Or if you have structured data, think tables. A lot of the lists that we find in Blackbaud, right? Those are going to better fit into an example of a data warehouse. All right. And in reality, most of the solutions out there combine the two ideas and produce what are called data lakehouses. I know, so inventive. All right. And in this talk, I'm going to talk about BigQuery, which is a data warehouse that exists alongside Google's data lake, which is cloud storage. And we'll see how those fit together. The last layer is, now that you've had data extracted, transformed and loaded into some data storage, all right, the next and final piece that you need is some layer of governance and business intelligence. All right. So for example, I know a lot of people here, especially if you're interested in the BigQuery because it has Google in the name, you may have heard of Google Looker Studio, which is Google's built-in BI tool. Or if you work on the Microsoft side, then I'm sure, have heard of Power BI. Right. But, these are the place where the actual analysis and reporting happens. The piece that I think often gets overlooked, though, is the governance. So, having some sort of way or tool of controlling who has access to your data. And there are literally hundreds of different tools. A tool that we particularly like at the Downtown School to achieve this, and also the BI at the same time, is Metabase. All right. But I won't really get into Metabase today. So maybe that's a follow-up next year, is like, how do we take data from Blackbaud and after we've done all the storing and transforming, how do we actually use it in Metabase? I do want to point out that while I think those 3 layers are the essentials and a great place for especially nonprofits and schools, smaller organizations to start, just some awareness in terms of there are additional layers if you were to continue to mature your architecture you could consider. So one is within your data orchestration, there's usually an opportunity to do some form of transformation. More sophisticated transformation happens typically in other platforms. In enterprise, they use things like Daxter or dbt Cloud. Those are specifically for monitoring those transformations, doing things like testing, version control, very sophisticated stuff. Second, on top of the governance piece, there's also a cybersecurity aspect of having observability over what data is flowing from one system to another, having things like data lineage or timestamps to track exactly when data gets changed or where it changes, or more importantly, like where doesn't it change and perhaps exposes some data. And then, of course, data security is just a broader sort of set of tools that maybe think of, your data warehouse as being a cloud asset that needs to be managed. All right, so great, Hudson. Why all the layers? That seems maybe a little overcomplicated, and the reason why is that actually the complexity simplifies some of the pain points that your organization is undoubtedly going to experience as you continue this type of work. And so one major feature of these layers is that it's modular. All right. In data engineering, one of the things that you want to avoid are systems that are tightly coupled, meaning like they have to change together in order to continue to work. So by having a more modular system, we're future-proofing, because if one piece of our data workflow were to break, say for instance, Blackbaud changes from on to Sky API, all right, then you can change the one piece that is responsible for handling that change without impacting the rest of your workflow. It also makes it a lot easier to track those specific issues. Where do the things perhaps break, or as you're building out, help you troubleshooting the setup. Also, you can control who has access to the various layers. Not everyone needs access to the full stack, right? For us at the Downtown School, it's great for me and one other admin to have access to the data orchestration and then the data storage, and then open up the governance and BI piece to more people to help democratize the access to that data without necessarily exposing everyone to all the engineering that went into the first 2 pieces. And also with the modularity, of course, we can easily reverse any changes at one without impacting the availability of data in another place. So this can happen if, we have a dashboard that's tied to data in our data storage, and we want to tweak or add something to that, right? We can just go into our data orchestration tool and modify it there, and still have the dashboard completely up and running. And the dream of like, if there was a tool that could do all these things for us, like that would be amazing. I know there are some solutions that claim they can do this, but spoiler alert, they're way too expensive for all of us and are also too clunky, I think, for easily onboarding. So I'll talk a bit more about our architecture, but another reason why I want to point out why we might go to all this work to set up these different layers is this problem of how do we better model our data? So one of the things I'm going to mention as part of this workflow is a bit of data modeling work that we're doing at the downtown school to make the usability of our data much better. So what does it mean to model data? And there are a lot of technical definitions, but I think the simplest definition for our use case is it's just a way of organizing and standardizing the data to make it useful and make it believable, right? Oftentimes, I've looked at a database and said to myself, like, no, I don't know. Sure, this may have come from the database at some point, but is this actually what's real now? And then also understanding, like, what the heck do like these 10 IDs mean within this table, right? How do I even join or relate these things together? And so data modeling is just a process of making sense of all that and restructuring the data for the user. And, again, if that doesn't convince you, I think we've all seen this nightmare. If you've opened up, say, Postman, or have ever pulled data via an API, you've gotten a response like this, and you're like, oh no, yeah, there's way too many fields that I don't know anything about. There's all this nested data. All right, it's just too complicated to expect an end user to make sense of. And so, as we're talking about how we might create a data model within this stack, a couple of things to keep in mind for what makes a data model good. Definitely that's minimal, all right? So the tables are only going to contain relevant information. You try to make sure that there's little or no, or ideally no overlap between the multiple tables that you've created. So that helps with, identifying where particular information is stored. You're going to reduce confusion between, like, should I be looking at this table? Should I be looking at that table? Also, it's better just for reducing overall storage. Also, making sure that your tables are linked together to be able to, have that kind of separation via unique keys or unique foreign keys between them. And then also making sure that they're normalized. And again, this could get a lot more technical, but at its base, right, just that there are no nested values, right? In this example here, we see all of these curly braces, these sort of like nested JSON responses. Yeah, normalized data, we get rid of those. Each column is unique, has a single value. Which I think is, at least in Blackbaud's case, they've done a good bit of the data modeling for us to an extent, and at least we can guarantee some of these things. And then each table has unique primary key. The partial or transitive dependencies, I would say, is sort of a nice thing to have if you are going through the full academic exercise of completely normalizing your tables. The idea of a transitive dependency is just that if you change one value within your table, you're not inadvertently changing the relationship or values of other things in that row. For us, I think it's fine if we don't totally remove those. So I've talked sort of just about the theory of this work up till now. I want us to start getting into the actual tech stack that we use at DTS and walk you through a demo of how each of these pieces work and relate to each other. All right. So it, of course, starts with where does our data originate from? And most of our data does originate from Blackbaud. I think, like a lot of schools, we live in this reality where, unfortunately, whether it's because of an association that we're part of or legacy software that we've been using, not all of our operations or data can exist within Blackbaud. So these are just 3 of our primary sources: Canvas, Blackbaud, and Ravenna. And then our data orchestration tool is Airbyte, that takes the data from all those sources. We are using a tool called dbt to be able to transform it. I'll show you what that looks like. And then the storage is all going into BigQuery, Google's data warehouse solution. And then, like I said, there are multiple governance and BI tools that we could use. And the great thing about having your data stored in BigQuery is that it is one of the most popular data warehouse solutions out there. So there are connectors built from it to most any governance and BI tool out there. So we connect it to both Metabase and Looker Studio, depending on our use case. And again, if you're like, hey, Hudson, we're not necessarily interested in all those specific tools, there are tons of choices out there, again, depending on your comfort. So again, instead of Airbyte, Power Automate, Prefect Mage fit into the same kind of slot. The same ideas will apply. And then if you're like, I'm not into Google, Azure Synapse or Amazon Redshift, depending on, which of the other major cloud providers you use, change out Looker Studio for Power BI. The principles still hold. But what I'm going to demo for you is exactly what we use at the downtown school. All right, before I open that up, though, I just want to check if there are any questions from the chat. All right, no, it looks like we're good. So I'm going to stop sharing. And I'm going to share my screen. And then for a second, forgive me, I'm going to do the cardinal sin of moving my primary screen over. So that's why I'm looking off to the side. That is a great question. I'll address is Airbyte open source in a second. Yeah, so let me talk about Airbyte, and this is it open right now. Airbyte at its simplest is a tool for connecting data from a source A to a destination B. It is a paid cloud service, or they do have an open source self-hosted version. And because of costs and a relatively simple use case for us, we are self-hosting our instance of Airbyte right now on an on-premise server, but we are going to be moving it to Google Cloud to host on a virtual machine there, which will actually be really nice because we can add in some additional security features like identity-aware proxy, so you have to authenticate through Google to access it. But yeah, I find it's pretty simple to set up the open source version. If you're experimenting or want to just get going like as fast as possible, you can host this locally on a machine while you're setting things up and then migrate it to somewhere else later. All right, but like I said, this is just about setting up sources and destinations and then connecting them. If you're curious like what all these different connections are, I used the same environment for a workshop I did at the Atlas annual conference earlier this year. So these were a bunch of just examples that people made. All right, but let me show you the sources. And in general, there are tons of pre-built sources, both from Airbyte, the company, and from members of the Airbyte community. Unfortunately, Blackbaud, you see it here, but notice it's custom. It's not something that people had already made. Maybe that is a project that is in the works by myself and maybe one or two other individuals. But for now, this is a source that we had to create a connector for. All right. But this is also great if you have data in other places that you might want to try to unify somewhere in a data warehouse. You could go through the setup process here. And then for destinations, it's the same idea. If you don't use Google BigQuery, right, there's still all these other places where you might end up storing your data. So for instance, if you are in AWS, right, you have the options for things like Amazon RDS for Postgres, or DynamoDB, AWS Data Lake. If you're in Microsoft, right, then you have the option to be able to put into some sort of SQL Server or Azure Blob Storage. All right, so you can, again, configure this to work within whatever stack that you're using. So you set up your source and you set up your destination, and then you form a connection between them in literally just a few steps. All right. So let me show you the connector that is sorry, the connector that we built to be able to do this. All right, and then I'll show you what it looks like with the connection that I've already made. All right. Now, this was a big update to Airbyte about 1.5 years ago. They released this no-code connection builder. All right, which if you have ever used a tool like Postmate, sorry, not Postmate, you can tell maybe it's getting close to lunch for me. Postman, if you've ever used Postman, all right, this interface might seem very familiar to you. All right, when you build a connector, you essentially put in you start by putting in all of the base API information, and then the method for authentication that's going to be used to access the API. All right. So if you've ever built an app with Blackbaud, or if you haven't, I will share. I have some videos that you might want to follow up with. Right? They have a really well documented process in this authorization code flow tutorial that walks you through how to set up an application, to also establish a refresh token, and then you insert that information here, and all of a sudden you are able to connect to various endpoints. Now, these endpoints, there's no way that Airbyte just knows what these are, so you do need to configure them. So to create a new API connection to a specific endpoint, what I typically like to do is I go to this guy API documentation and I say, hey, what is something that I want to pull data over from? We're a school, so academic courses seems like a logical thing. All right. And so I take this URL and I put it in here. And then we end up with a screen where we can configure exactly what we are trying to pull. Now, while I'm going through this a little fast, you're like, Hudson, you're skipping a lot of stuff. The good news is that because this tool allows us to develop in a way that could be shared with others, you don't have to necessarily recreate this from scratch. And in the future, I'm actually planning and hoping that we'll have a community version that has every endpoint from the Blackbaud Sky API available here. All right. In the short time, if you decide you want to actually start playing around and making this yourself, then I am happy to share this YAML file that is generated here as a starting place for you. All right. But we can see over here this data that is getting pulled from this specific endpoint. And so if we go into a connection, all right, you'll find a few things. All right. The first is you'll find the status of any sort of data pool that is available after you set it up. But where we actually configure which data is going to be transferred from Blackbaud into whatever destination we pick, we click on the replication tab and we see all the endpoints that were configured in the connection builder. And if we click on each of those, we can see even more specifically what are all the individual fields coming from that API endpoint here. And we can toggle this. This is great. Like, remember me complaining that there's just way too much information? This is one place where we can start to deselect things that aren't necessarily going to be needed in our data storage. And then we can even toggle on and off entire endpoints altogether. While I'm here, I just want to point out something that's nice is it's a pain, right? If you have to go and update all this data manually, right? Part of the point of data orchestration is to avoid that. We can set a scheduled job that will run however often we want from a given point, or if we want to have it run, say at 12 p.m. every day, we can do these cron jobs. We can also specify how and where the data will be stored. Think of this as like folders. I'll show that in BigQuery here in a minute. All right, but this gives us a lot of granular control over the way that the data, when and how the data is going to be pulled over. On top of that, I'll also point out that we have really good logging here to see exactly how and when things ran. So for instance, here I can tell this was earlier in May, someone must have been playing around with setting something up. It failed. All right. You can go into and view the logs to see exactly how it failed. And again, this is part of that governance piece of knowing exactly where data is and when and how is it being moved between your systems. And there's no deleting any of this, right? So this is a permanent record for all of your data flow. All right, so I want to show you what does it look like after we successfully run a sync. And this is where our data warehouse comes in. So I'm on Google Cloud. Here we're in BigQuery. Sorry, I'm looking over here at the question. Sorry, I saw this question about Airbyte, and I want to answer it for a minute. So do not have experience with School API. However, I do have a lot of Razor's Edge Sky API, and one of the more difficult things is pulling updated data. How does Airbyte handle iterative loading, or is it always full load? So you can configure it to do incremental loading. So it will look for changes, and then you can push only the new responses to your to your destination. Or you could also do a full overwrite, and it would just do a completely updated table in your data storage. For us, there's not really been a use case where doing the full overwrite hasn't been fine, but we could do the incremental. Can you use a last modified? So if there is if there's a query parameter that allows you to specify, say within your response, you can specify the last modified, then yes, you can add that kind of configuration to your Airbyte connector. So there's a lot of really granular control that you can add on, and I'll just again go back in here to show you. So like I said, if you run into issues with things like pagination, they give you ways to handle that. This is where you can do the incremental sync. One of the things that I have set up and explained in more detail in these videos that I'm going to share with you at the end of the presentation, say you have an endpoint that is pulling from an individual row based on an individual ID that you might have gotten from another table. So for instance, well, I don't want to take too long with this. So just to talk through an example here, all right? Say you want to get all of the attendance records for all your classes, right? There's perhaps an individual attendance endpoint saying, take a class ID and give me the attendance records for that ID, that class, all right? What you can do is you can have the endpoint that pulls all the classes and then feed that as a parent stream into this to be able to then get each of those make a API call for each of those individual IDs, and then it will still just aggregate and put it all together into a single table. And then you can also do things like parameterize requests and error handling, and then a little bit more advanced, but you can apply transformations at this level too. So after you've configured everything, all right, where does it end up in your data warehouse? And this goes back to the like within the connection that I mentioned here. Here we can set what the namespace, what this destination is going to look like, and then we will see there's this folder, this data set within BigQuery created that contains all of the data that's been synced over. So if I click on, say, core students, we can see all the data coming from that API endpoint here. And this at its most basic level is how we can get our data into our storage and then start getting into the into things like reporting, analysis, sharing, right? Again, one of the benefits of putting it into this is it interfaces, it connects to all these other tools. Or even more simply, this is one of the things that we've done with a couple of our data sets. You can even explore them directly in Sheets and then treat it just like any other spreadsheet where you can then share it with particular groups or users in your organization. So one of our use cases for this is we pull over all of our narrative comments from comments from Blackbaud, and we store it into our data warehouse or into BigQuery, and then we do this kind of export as a sheet where we filter and share it specifically to the teachers based on their name or ID, so that they can go through and they can see all the narrative comments that they've ever written in a spreadsheet like this, and that they're not actually going to get access to anything they shouldn't have access to, and also can't actually change the underlying data. Or if you are into reporting or BI tools like Looker Studio, you can directly connect it into Looker Studio like this. Now, I think beyond just simply being able to do this, the power here of having all of this data in your data warehouse is, look, this is just one source, right? Remember the other sources I mentioned that we use? We can put data from Canvas. We can put data from Ravenna. We can put data from surveys into here. And now we have the opportunity to join and put together this information in more interesting ways than perhaps if we were just to work within any one tool. Now, the last thing I'll mention is you may still look at this and you may say like, hey, Hudson, let me find a good example. Okay. So let me zoom out a little bit. All right, so let's look at, so this is an example of an advanced list that, sorry, this is not an advanced list. Sorry, this is an example of an endpoint being pulled out that has quite a bit of fields to it. All right. And again, if we sort of look at it, maybe the data is not presented in the nicest format. There are these columns where we have all this sort of like nested data, nested responses. The question of how do we make those nicer and more usable, this is where the data modeling comes in. And within Airbyte, the data modeling tool that they sort of make easiest to use is a tool called DBT. Now, when I first heard that I was going to have to learn how to use a tool called DBT to do this transformation, honestly, I was kind of annoyed and intimidated that, oh my gosh, I'm going to have to learn a new tool. Then I realized all DBT is really a sort of a scripting language, a wrapper around SQL. So at its base, right, it's a super language of SQL. At its base, if you know some basic SQL or can modify existing SQL you can do transformations using DBT. So I'm going to show you what that looks like. So this connector is making use of a DBT project that I've made and I've posted in GitHub. There's a lot to this, but at its most basic, and this is all sort of like pre-generated boilerplate, at its most basic, we're just creating models, right? That's what I said this was designed for. It's to create models. And I'll show you exactly what a model looks like. It's just some SQL, all right? This here is actually the SQL that would be needed to take an advanced list, right? Advanced lists, if you ever use them with Sky API, unfortunately don't get returned in the most useful way. This is where I want to show you an example of an advanced list as it appears in the API. All right, you might already be skeptical and curious here, like there are only 4 columns, one of which is called columns. So we know we're doing great here. And if we preview it, oh no, it looks like all the data that we actually want is in this nested data in this column called columns. So this is where, a tool like DBT for this kind of transformation can actually make sense of this. What this code is doing, and I would point out really that this first part here is a template that would be used to do any kind of transformation on advanced list. So the part that actually matters here is just this right here, where we just simply say, okay, extract the values that we know should be in these columns, like the things that we actually set up when we made our advanced list. All right. So we're going to select those and then rename them into something more useful. And the end result here, where we've saved it into this different data set to separate out our models, is a lot nicer. And also within DBT, one of the nice things is we can specify a schema description, which actually, again, the point is to make this more useful for other things. So that is our entire flow, right? From having data in Blackbaud or any of these other sources and getting it into our data warehouse where we could then make use of it elsewhere, right? So it starts off with our connection in Airbyte using the custom connector that we built. Again, this is something that either you can use someone else's connector for. So I'm happy to share mine with you. And again, hopefully we'll have a community version built sometime not too far out from now. To being stored into BigQuery, our data warehouse, to then transforming some of the tables like advanced list or some of these messier tables into more usable tables using DBT. Now, that is a lot and not as detailed as you might hope for, which is why, I'm happy to share that I've already done most of the work of documenting this in much more depth. Yes, my GitHub repos are available through, thank you to Ruben for posting that in the chat. But also I have a LinkedIn post that I'm going to put a link to in the chat. That has links to all the GitHub files that you might need for this work. Also to a archive of Loom videos going through not even just the setup for Airbyte and DBT and BigQuery, but if you're actually interested in the entire infrastructure that we use at TTS, this goes through exactly how to replicate that architecture yourself using Google Cloud. All right, and I'll stop looking off into the clouds, bring my screen back over here. But I just want to wrap this up by bringing it all back to like, okay, to what end? Like, what is this work for? All right. And again, for us, it's about being able to have easier access to our data across all of our multiple sources and being able to combine them in ways to unearth more interesting insights than we can simply get from one tool. So we can do things like automated grade analytics, which is a little bit complicated if you're like us and you perhaps data in 2 different places, your LMS and your SIS, and you're trying to see how do those actually reconcile and compare to each other. right? This is one way of doing that. Also for attendance tracking, right? Instead of having to go into some special report or into or going into like individual students to see a better breakdown of their attendance, we pull it all into one place and can sort by who has the most absences, the most tardies. We can filter that by a grade. We can also do sort of things that are a little bit harder to get at, things that typically only live in advanced lists, like detailed notes about infractions or official notes. This is actually maybe a future topic for next year. All right. Having that data in BigQuery, which is in an enterprise, it has enterprise data connections, we can actually leverage things like AI directly within BigQuery to do analysis of those comments. So that's one of the things that we're working on, is how to better leverage AI to make use of all this data that we currently have stored in BigQuery securely. And so that's pretty much everything I had time-wise. Yeah, we got like 4 minutes. So I just want to say thank you. And certainly if you have questions that you would like to follow up with, you can email me. But I'm curious if there are any questions right now. So I see Shannon, the biggest issue we've had is pulling deleted. So we have to rely on refreshes far too often. Yeah. Yeah. That's a problem. And that's going back to like a bigger data governance issue, just like how do we train people to process data in a consistent manner, in a predictable manner? That I unfortunately don't have a solution for you in this presentation. All right, but anyway, I hope if you're at all interested, check out the videos. It goes into much more detail, breaks it down much more. And please, if you have questions or would like help or just would like to, brainstorm through things, let me know. I'm always happy to Zoom in with people.
And I'll just jump in here. Thanks, Hudson. Awesome presentation. I've added a survey here. If everybody could take just a few moments and fill out that survey so we could get back that this was an awesome presentation back to our organizers. Thanks so much. All right. Thanks, Hudson. Have a great day.